Hi, in this video we're going to talk about the details of setting up parts and cycle times and some of the rules that are associated with parts and cycle times. So I'm going to add a part to start this process. So the part number field is really just like the part number field inside of your ERP system or really anywhere else. It's typically a code. Sometimes it's a smart code that identifies this particular part number. The description is a human readable description. It is what shows up in most of the drop down boxes throughout the system. So let's make maybe like a 20 tooth sprocket as a part. Okay, and then we can enter the cycle time. Cycle times can be whole numbers or they can be decimals. And then we have a lot of different units of measure that the cycle times can be measured in. So parts per second, seconds per parts, minutes per part, parts per minute, and so on. So you can express it how you really want to see it. And when you see cycle times in the system, they're going to be converted into the cycle time unit of measure that you want. SensorTrax does have a base unit of cycle time, which is parts per minute. So you may see that throughout the system too, depending on how you select things in the dashboards. So for this particular part, let's say we can do takes 10.5 minutes per part. And then down here we also have co-parts. So co-parts are if you are running the same parts on the same piece of equipment. So let's say I have a black sprocket and a red sprocket, and they run together on the same equipment. They have the same cycle times, but really what I want to understand is the quality difference between the two. I want to collect quality issues on both the black one and the red one. So you may want to set up co-parts there. So this will give us a drop-down box of all the different parts that we have in the system, and we can choose those. Cost is the cost of the finished good for this particular part. So if you put that in there, we will calculate the cost of scrap. So every time you scrap out a part, it will increase your costs. The job required flag is just what it says. If you turn it on, we will require a job when a production record is started or when you change one over. Master part denotes that this is a master of the co-part. So basically what that does is it says anytime I start this 20-tooth sprocket, I also want to start its co-part. And this is the one I choose to be able to do that. If master part is not turned on, you won't be able to select this part in any of the drop-down boxes throughout the system. Ignore performance on the part level allows you to ignore the performance calculation. So for example, if you don't know your cycle times, or maybe you don't really care about your cycle times while you're monitoring an individual machine, you're more interested on looking at availability or utilization. If you turn this on, it will set performance to 100%, no matter what the performance actually is. And the same is true for quality. So if you want to completely ignore quality, you can do that as well. And you can turn these off and on independently. Okay. So cycle times work in a hierarchy, and actually the ignore performance and ignore quality do too. So the system goes from the most specific cycle time to the least specific cycle time. So the most specific cycle time is really here. It's on the cycle times page. And this is where you can define a cycle time per machine for a particular part. So I'm going to save this real quick and then come back. So let's go back here and take a look at cycle time. So what this allows us to do is say, hey, on this grinder number 1, maybe the cycle time's not 10 minutes per part. Maybe it's more like 5 because it's a newer machine. It runs a little bit faster, right? So we can set these up that way. When you do this, it also controls which parts can be selected in the manual entry parts of the system when you're reporting production. So when we talk about the cycle time hierarchy, we look at it from most specific to least specific. So again, the most specific is the combination of a machine or a cell and a part, which is what we're seeing here. So this is the 20-tooth sprocket running on grinder 1. So if the system finds this, it's going to take this first. If it doesn't find the machine part combination, it's going to look at the part number cycle time next. And if for some reason that doesn't exist, so if there was no cycle time on this 20-tooth sprocket, it's going to jump up to the grinder itself, or the machine that it's running on, and get its cycle time. So here we'll see that the default cycle time on the machine is 10 parts per minute, regardless of what part is actually running on that machine. So most specific to least specific, the cycle time tab first on parts, right? So we're going to look at here. Okay. Then it's going to look at the part, and if it doesn't exist on the part, it's going to go look at the machine and the cell. So we can take a look at this information and really understand what it's doing by looking at our report production page. So we had some downtime there, so let's mark it as downtime. Because in the report production page, we have this little helper that walks us through all of our OEE calculations. And so here we'll see, when we're looking at performance, that our ideal cycle time in parts per minute, okay, is 10. And then our actual cycle time, parts per minute, is 1.295, right? So that we know, if we look at this, essentially where that's coming from. So if we go back into the part setup and we look at Sprocket 1, because that's what we were looking at 10 parts per minute. Okay. So hopefully that explains how cycle times work in the system and how the hierarchy works for cycle times. So the first place the system looks is the cycle times tab. So in this example, it's not going to find one here. Then it's going to go to the part, which is 10 parts per minute. And then if this wasn't here, it would look at the actual machine, which is also 10 parts per minute.